Hey guys, so this is question 16, 17, and 18 off your study guide. We have a cannon that's shooting off a cannonball at 25 degrees and the speed is 42 meters per second, or the velocity rather. We are ultimately looking for how long it's in the air, which would be our time, the height that it reaches, and the range, or which would be the horizontal distance that the cannon travels, right? So the first step you're actually going to need to do before you try to answer any of these is going to be break down your VIX and your VIY. Anytime you're given an angle in these problems, you're going to need to do this step. Whether there's a question telling you to do it, like the previous set, like 13 asked you to do, or like in this case, it does not ask you. So your formula for VIX is going to be VI cosine theta. So you've got your VI is 42, and then cosine and your angle is 25. So when you type that in your calculator, you should get 38.06, and that's meters per second, because it's velocity. Alright, then your VIY is going to be VI sine, that's an S, theta. Alright, so that'd be 42 sine 25, and then when you type that in, it is going to give you 17.75 meters per second. Alright, so that's your VIY. So that's your first step. You're never going to plug in that 42 meters per second anywhere else than where we just did. So from here on out, these are your velocities. So for my table, alright, I've got acceleration, distance, time, VI, VY. So I've got my acceleration and my horizontal is always 0 for these, and my y is always negative 9.8 because it's due to gravity. My VI for the x is going to be that 38.06, and my VIY is going to be 17.75. Alright. Alright, so for 16, we want to know how long it's in the air. So when we're shooting off this cannon, it's going to make it's going to follow a path like a parabola. It's going to look like this. So we want to know how long it takes it to get from start to finish. However, we don't know enough information to find that immediately. What we can do is find the time it takes to get to the top, and work with the vertical information. Because right here at the very top, just like when we throw something straight into the air, its VFY will be 0 at that point, at the very top, because it's going up and up and up. Eventually it has to start coming back down. So at that moment that it reaches its highest point, its velocity is 0. Alright, so VF at that point is 0. So for 16, we can use the formula VFY equals VIY plus AY times time. And we can solve for time. So we can plug in the 0 equals the VIY we just found of 17.75 plus negative 9.8 times time. Alright, so when you solve from here, you want to bring the 17.75 to the other side by subtracting, because that's being added to the negative 9.8 times t. So this would be negative 17.75 equals negative 9.8 times time. Then you would divide both sides by the negative 9.8 to get t by itself, and that is going to give you t equals 1.8. Alright, so the time it takes it to get to the very top is going to be 1.8 seconds. However, our question says how long it's in the air. So it is still going after it gets to the top. It's got to come back down. So you're going to double this number, and it's going to be 3.6 seconds total to get to the very end. So it takes 1.8 seconds to get here, and then another 1.8 seconds to come down. Alright, so that is 17. Let me erase some of this to make room. That is a tiny eraser, and apparently that's as big as it gets. So for 17, we're looking for heights. So it takes it 1.8 seconds. Apparently my app is memory overloading right now. It just gave me a warning message. Sorry. So it takes it 1.8 seconds to get to the top. So right here, That's my highest point. It's halfway through. So we're not going to use the 3.6 seconds. We're going to use the 1.8 seconds. So we can use our distance formula of Vy equals VIY times time plus 1/2 AYT, which we're going to use squared, is what we're using a lot. So you've got those 17.75 times the 1.8 plus 1/2 negative 9.8 times t squared, 1.8 squared. All right. When you plug all of that in your calculator, you should get 16.07 meters or something close to that. So your cannonball is going to reach a height of 16.07 meters before it starts coming back down. If you had plugged in the 3.6, you're probably going to get an answer relatively close to 0 because it's going to tell you it's back on the ground, or, because of rounding, it may not give you exactly 0. All right, so your vertical height is going to be 16.07 meters. To fill in number 16, that was 3.6 seconds total. All right, the last part is your range of your cannon. Your range that's another way to say horizontal distance. And in order to find that, you are going to use the full amount of time because it's taking the full 3.6 seconds to get all the way to the end. So you're going to use that distance formula again, but this time using the x information. All right. All right. Your AX is always 0. We had that written over here. So all of that gets canceled out. So anytime you're finding range, you're actually just using the first half of the formula. So you're going to take your VIX, which was 38.06, and then your full time, which is 3.6. And when you multiply that out, you should get 129.8 meters. So this cannon is going a total distance of 129 meters away is where it's going to land on the ground. All right. So it'll go up to a height of 16 at its peak. It'll land almost 130 meters away, and it's going to travel for 3.6 seconds total. All right. I know this video is lengthy, but I hope it helps. Please let me know if you have any questions.